Students, just
This call is now being recorded.
yeah. RSA. So about RSA, the problem statement is given like this. Write a program for simple RSA algorithm to encrypt and decrypt the data. So what they have asked, you have to implement a simple RSA algorithm using Java language, where you have to show the encryption of the data as well as decryption of the data. Is my voice audible to everyone?
Yes, ma'am.
Okay,
Yes,
okay,
ma'am.
fine. So RSA stands for Revisit Shamir Adleman. Okay, so these are the scientists who designed this algorithm RSA. As you know, this RSA is very popular encryption or decryption algorithm which are used in modern computers, okay, to encrypt our data, or it may be decrypt the data. And it is the two types of cryptographic algorithms are there. One, the symmetric, and another one is asymmetric cryptographic algorithm, where this RSA comes under asymmetric cryptographic algorithm. So in symmetric cryptographic algorithm, we use the same key, that is private key, between two parties who are involved in the communication. So the same key will be shared between two parties, right? Whereas in asymmetric cryptographic algorithm, private as well as public keys are used. So two different keys are used in a symmetric cryptographic algorithm. So it is also called as public key cryptography. So let me consider this example. See, from the company Microsoft as well as Netscape. So these two companies, what they have included this RSA algorithm in the web browser itself. Okay, let me consider real-time example where we in our day-to-day life we will be browsing many data, right? We will send requests to many servers, isn't it, using browser. So let me consider that example here. Being a client, consider I'm a client with the help of browser, say Chrome, Firefox, or whatever browser that are available. So using that browser, I'll send a request to a certain server. It may be Yahoo server, or it may be Google, or any server. Okay, so what I will do, so before, along with sending the data, request data to a particular server, I will send a public key. Okay, so along with the request, what I will do, I will send my public key to the server, and I'll make request for some data. Okay, say I want to know more information about RSA algorithm. I want to know the examples under this algorithm. Okay, consider that as an example. Example for this. So that request I will send it to, say, Google server. So along with this request, I will send public key to the server. Okay. Next, what server will do once the request is accepted? What server will do? It will encrypt the data. Whatever the request I made it to the, I have requested to the server will encrypt the required data for the user. Client. So server will encrypt the data using client's public key. So whatever the public key I had sent to the server, using that key, public key, the server will encrypt the requested data and send that data to whom? To the client. So that data we call it as a encrypted data. Now, what client has to do? Once this data is received at the client side, he has to decrypt it, right? So we can't read the encrypted data. It may be maybe some using special characters or numbers that will be created. One second. So once the decrypted data is received, what client has to do? Client will use his private key to decrypt this data, decrypted data. So once he applies this private key, he can receive the required data and he can carry on with his work. Okay. Now, if we use this asymmetric method, no one else, say attacker or intruder, except browser can decrypt the data, right? So can decrypt the data because private key will be known to only the client, or you can say only to the browser. See, even though public key is available in the public domain, he can't decrypt it, right? The person who is having the private key, only that person can decrypt the data. Not everyone who has the public key of the browser can decrypt the data. So this algorithm is used in most of the modern computers which are involved in the network communication. Okay, this is the brief introduction about this RSA algorithm. So here, working of RSA algorithm, whatever I explained in the previous slide, I just represent it in a big form, image representation, okay, with slide changes. Say, consider this is one user and this is another user, Alice and Bob. So these two people wants to communicate. They want to share some data. So Alice wants to send a data to the Bob. So what she will do, if we are using RSA algorithm, she will create the message first, okay, and then using Bob's public key, she will encrypt the data. So, or I shall use this 1 second. Let me use the mark. Okay, so what Alice will create a message, okay, using Bob's public key, she will encrypt this data. So now encrypted data is ready. Once this encrypted data sent to the Bob over the network channel, what Bob will do, he will use his private key to decrypt the data. Again, he can see whatever the sent message from the Alice end. Okay, so here you should know Alice using the public key of Bob. Okay, once the message is received, the Bob will decrypt the data using private key. If public key and private key here, if it works properly together, then only he will receive the proper message. Okay, yeah, that is one more example here. And now we'll directly see the algorithm part. Okay, the steps involved in this algorithm. The first step is that you have to choose large random prime numbers. So you have to choose two large random prime numbers. Let me consider it as P and Q. Okay, what are those numbers? Do remember, these numbers should be the prime numbers, okay, which are randomly generated here. So you should consider two large random prime numbers. Let me consider that as P and Q, okay, and let these two approximately equal in size. Okay, this is first step. So see, if you remember this algorithm properly, then it is easy to understand the coding part. Okay, let's see the second step. Second step is what? You have to perform the multiplication operation on these two prime numbers. So perform multiplication on P and Q. So the result value will be stored in a variable called n. Okay, this is the second step. Next, third step is that you have to find, you have to perform the multiplication P minus 1 and Q minus 1. Subtract 1 from P and subtract 1 from Q and multiply these two values. Once you multiply these two values, whatever the result value you will get, that will be stored in another variable, that is Z. So what is the first step? You have to consider two large prime numbers, random prime numbers, that is P and Q. Then perform multiplication on these two random numbers. Okay, then n. Okay, now you may be thinking why we have to do all these steps in the algorithm, right? So you should remember, we need a key to perform encryption and we need a key to perform decryption, right? So that's why these are all the steps involved in this algorithm. So once you have the Z value, then the next step is that you have to choose an integer E, okay, whose value should be greater than 1, and it should be lesser than Z. So do remember what you have to choose integer E in such a way that it should be greater than 1 here, okay, and lesser than Z. Where will you get the Z value? You will get it here from the previous step, okay, such that, okay, perform GCD on E comma Z, and that should be equal to 1, okay. You have to perform E in such a way that it should be lesser than 1 and greater than Z. When you perform GCD on E and Z, it should be equal to 1, okay. This is the next step. We'll see after this. Again, you have to compute secret exponent, that is D. Okay, now you have to find out what is D here. Again, D should be lesser than 1 and I'm very sorry, it should be greater than 1 and it should be lesser than Z. Okay, such that E into D should be equal to 1 mod Z. So you have to choose the D value in such a way that it should be greater than 1 and lesser than Z. When you perform this multiplication, it should be almost equal to 1 mod Z. Okay. Then whatever the variables that we have calculated till this step, that is N and E, these two variables, N and E. So these can be used as public key. Okay. N and D can be used as private keys. So in the previous example, we saw we need public key as well as private key to encrypt and decrypt the data, isn't it? So to obtain these keys, you have to perform all these steps. Okay. First, find out prime numbers, perform multiplication on that, and then compute Z, and then choose an integer such that it should be greater than 1 and lesser than Z, and perform GCD on E and Z where it should be equal to 1. Then compute the value of D in such a way that it should be greater than 1 and lesser than Z, such that E into D almost equal to 1 mod Z, where N and D will be the public key, N and D will be the private key. Okay. Is this clear till this point? Because this algorithm should be clear to everyone before you understand the code part. Okay. So is this clear to everyone till this point?
Yes, ma'am.
Yes. What about others?
Yes. Yes, ma'am.
Okay, okay. So we'll move to the next step. So here one thing you have to remember, the values of P, Q, Z should be kept as secret. Okay. So next, see, once you have this key, what is the next step? You have to perform, or you have to create the encrypted data, right? How do you perform the encryption here? That you can call it as cipher mode. So the encrypted data is called as ciphertext, right? So the next step is you have to find out the cipher code. How do you calculate it? M power of E. M is nothing but the message that you want to send it to other user who is involved in the communication. So, okay, this message M power of E. E is what in the previous slide we have calculated. It's an integer, right? And mod N. N is what? Where we, in this, here we calculated multiplication of P and Q. Okay, this is ciphertext to generate the encryption data. Next is what? After performing decryption, you will get the original message, right? So that how you can do it. C power of D mod N. Okay, C is what? This is cipher code. Cipher code is C. Do you remember this? Power of D. D is what? In the previous slide, we calculated, right? Secret exponent. D. This one. This D. Okay. So this C power of D mod N. C is nothing but cipher code. M is nothing but here it is message. So to perform encryption, we'll perform this one. To perform decryption, we have to perform this operation. Okay. So these are the steps involved in RSA algorithm. First thing is what? Please you remember, find out two large prime numbers P and Q, then compute the value of N multiplying P and Q, then compute Z performing multiplication on P minus 1 and Q minus 1, and again choose an integer E where GCD of E and Z should be 1. Again compute the value of D where E into D must be equal to 1 mod Z, where N and D will be treated as public key, N and D is treated as private key. So with this basic idea, we'll just see how output will be seen on the monitor. So initially, I'll just compile this Java program and execute it. So we will ask the user to enter the data that he wants to send. Okay. So I have given it as hi Bangalore. Okay. So encrypting the string. So we have to encrypt this string. So this we are considering this same enter text. Okay. So this after encrypting the string in bytes, it is represented. Whatever you are seeing here, the large number, it is in byte format after performing encryption. Okay. Then the next step here, it's decrypting bytes. So whatever, which data we are going to decrypt, this one, this large value, we are going to decrypt it. That is what written in this line. Okay. And after decrypting, the same message should be retrieved, right? That is what is written here. Hi, Bangalore. So the plain text, this is you want to send to the another user who is involved in the network, I mean communication. So which data we are going to encrypt? That is hi Bangalore. Okay. And we have to convert this string into bytes. Okay. When after converting and performing encryption, this will be the answer for encryption data. Okay. Then once this encrypted data is received at other end, that data should be decrypted, right? So which data you're going to decrypt it? This is, one second, this, just a minute, this data we are going to decrypt it. After decrypting, what is the data received or message received? Hi Bangalore, which is same as the text we entered in the first step. Okay, this is what RSA algorithm is all about. Any doubts, dear students?
No, ma'am.
Okay, then we shall move to the coding part now. Okay. Yeah. Can you see this code properly? Is it visible to everyone?
Yes, ma'am.
Okay. See, in the first step here, we are just importing all the required packages. Okay. And then in the class RSA, we are going to declare all the required variables. Okay. You can see P, Q, N, phi, E, D, and all that. Okay. And start with this RSA function. Okay. What is the first step we started in the algorithm? Generate two large random numbers, and those two should be prime in nature, right? And also equal in size. So here we are going to generate P and Q by using the function probable prime. Okay, probable prime. See, actually, in actual implementation of this RSA algorithm, that means the practical implementation of this algorithm, they don't use hardly 3 digits of prime number or 4 digits of prime number. It will be a large number. Okay, so for that sake, we are considering here the data type as big integer. Okay, for all the variables, it's given as big integer. Okay, so by using probable prime function with big integer as a data type, we are generating a random number. Okay, that is using the random function here. Here you can see this package is imported here, random. So that random number is generated of bit length. Here the bit length is set to 1024. Okay, so the using probable prime, okay, we are generating the prime number P. Okay, using the same function again, we are generating another random prime number Q. Okay, that is first step. What is the next step? Perform multiplication on P and Q, isn't it? So see, you can't simply write P multiplied by Q using multiplication symbol here, because we have to perform operation on big integer here, right? So that's why we are using function called multiply. Okay, using this function, we have to multiply P value and Q value. Once you perform multiplication on this, the result will be stored in another variable called N. Okay, this is second step. What is third step? Compute Z. How do you compute value of Z? Subtract P minus 1 from P and 1 from Q. Okay, and that after subtraction, instead of Z, I've just written it as 5. Okay, you can write it as Z as well. Let it be, I mean, here I have considered as 5. Okay, how do you perform that? Subtract using subtract function. Okay, subtract 1 from P. Okay, subtract 1 from Q. Okay, after subtract, you have to multiply these two values. So that is what done in this step. Okay, next method is what? You have to choose an integer E, right? So that is, see, even this is also, we are considering it as prime number. Okay, using probable prime, same as this line, these two lines. Okay, using that, we are creating a prime number here, bit length divided by 2 comma, are using random function. Okay, so E here, it has to satisfy this condition, isn't it? So it has to satisfy this condition. What is that? GCD of E comma Z should be 1. Okay, so what we are doing here, comparing the values with 1 and with 5. Do you remember? Comparing E value with 1, okay, and you know it should be greater than 1. Okay, so that is given as greater than 0, and then E value, compare it with 5. 5 is nothing but what? Here Z. Okay, here in the explanation it is Z. Here in the coding part I've considered as 5. Okay, compare this. So if this condition satisfy, then that will be E value. Okay. If this condition holds good, increment E value by 1. Okay. So that will be the value of E here. Fine. So now we have the value of P, Q, N, phi, and E. Okay. Now, next part is what? You have to find out D value, right? That is nothing but secret exponent, which should be what? Lesser than, sorry, greater than 1, lesser than Z, right? And mod of these two E and D should be equal to 1 mod Z. So how do you compute? Here it's given. Mod inverse of phi. E dot mod inverse of phi will give you the value of D. Okay. Now we have P value, Q value, N value, E value, and D value. So using this, we can perform encryption and decryption, right? To perform encryption, what we need? N and E value, right? To perform decryption, we need N and D value. So we are ready with all the required values. Then we'll move to the main function. Fine. So here we'll ask the user to enter the plain text. In the example, hi Bangalore I have given, no? That is read from the user. After reading it, we have to perform, or you have to convert the string to bytes. Okay. That's why it is done using this toString testString.get bytes. Okay. So using this, you have to convert the entered string to byte format. Okay. Once the data is in byte format, perform encryption algorithm. Okay. Perform encryption part. So this function is given here. So you can see bytes to string, how it is converted. The function is written. Fine. So now directly come to the encrypt function. Here, what is the formula we have to follow? The message, that is hi Bangalore, power of E, that is calculated above, mod N. So that is what written here. Okay. Power M, this is message. Okay. Power of E, okay, mod N. Okay. So once you perform this operation, you will return with byte array. Okay. So that means you will be obtained with C value, that is cipher code. Do remember the formula, then it will be easy to remember this complete line function. Okay. M power of E, message power of E mod N. Okay. After performing this, it will return byte array. Okay. That will come here. Okay. That will be stored in this. Once you perform the encryption, then perform the decrypt part. Okay. Encrypted data should be decrypted here. Now directly go to this. The formula goes like this: C power of D mod N. C is what? The cipher code, whatever you have calculated here. Okay. C, then mod power D comma N. So the same will be calculated and it will be written here. Okay. So whatever calculated, encrypted and decrypted, that will be displayed using this system of print line statements. Okay. So this program is easy, but you have to remember the format in which you have to write each and every line. That is very important. So you should not make any syntax error while typing the code. So once you execute this, this will be your output. Okay. The same thing, hi Bangalore, encrypting string in bytes. What data you are decrypting? After decrypting, what is the data? So this is the output for this RSA algorithm. So that ends this RSA algorithm. So any doubts in this coding part? See, it's the simple one. You have to remember how to write each and every function and its syntax. since you have learned Java in your previous semester, I hope it's easy to follow you this program. Okay, so shall we see the online execution? One second. Okay, any doubts till now, student?
No, ma'am.
Okay, then we'll see the execution part. See, I'm showing you execution in online compiler. Okay, because you are trying it out in online compiler at your place, right? So that's why I'll just show you this. Not this one. CRC. Can you see this date code here? See, I have used jdoodle.com. So it's available. You can check it out. Okay. I've just pasted the code in this compiler here. The places provider. Just make this RSA class as public. That is one change. In the code which I sent to your ID, where I've given it as class RSA, just make it as public class RSA. Make this class as public. That's it. Okay. Okay. So this, I've just pasted this code. Fine. Then execute. So it takes few seconds. See, it's asking enter the plain text. So standard input should be given at this end. So is it visible to everyone? Are you all
Yes,
able
ma'am.
to follow this? Yes, okay. So here I'll just enter some text. Hello, SVIT. Okay, after entering this input, I mean message, again give it as execute. So you can see here, enter the plain text is hello SVIT. Okay, encrypting string is which data you are encrypting? Hello SVIT. So after converting it in bytes, I mean after performing encryption, this will be the data, encrypting data. Okay, again on this data I'm performing decryption operation. So that is what says here. After decryption, again the received data will be printed. So this data and this data is one and the same. So encryption and decryption is done properly using RSA algorithm. This is how RSA algorithm is implemented. Is this clear to everyone?
Yes, ma'am.
Okay, then we shall move to the next program. So, I mean, the execution of the programs which I couldn't show the output in the previous lab. Huh? So, distance vector. One second. Okay. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay, then we'll see how to execute distance vector, Bellman-Ford algorithm. Okay, I've just same compiler I've used, copied the code and pasted here, and I'm performing execution here. One second. I will close IO exit. So okay, I made a mistake. E should be written. E should be written in caps. IO exception. Yeah. Execute. Is this visible now? Enter the number of nodes. This program has been explained in the last class, last lab, isn't it?
Yes, ma'am.
Okay, so I'm just showing the output of this. It's asking enter the number of nodes. Okay, I'll give it as 4. Okay, and again click on this execution button. It's asking you to enter the cost matrix, right? You have to give it from the standard input device. So I'll just enter the cost matrix required for this. Okay, 0. I'm giving the one which you have it in your manual. Okay, 999, 2, 999, 999, 999, 999, and 5. And in the 4th row, all the values are 999. Okay, I've entered the required cost matrix here and then click on execute. So here you can see the distance between each node. So what? Router 0, 0 to 0, via 0, it is 0. So you are going to calculate the path between all the nodes via all the nodes, right? 0 to 0, it is 0. 0 to 1, it is 3. 0 to 2, it is 5. 0 to 3, it is 10. In the same way, with respect to 0, with respect to 1, with respect to 2, with respect to 3. With respect to all the nodes, it will calculate the distance between the nodes. Okay. So is this clear to everyone? Yes?
Yes, ma'am.
Okay. Now we'll move to the next program. Execution part we'll see. That is leaky bucket. Okay. Same compiler I'm using. I just pasted the required code here, leaky bucket code. Okay. So now I'll execute this code. I hope you all remember leaky bucket program. It takes few seconds. Enter bucket size. Let me give it as 10 bucket size. Again, click on execute button. Output rate as 4. Then how many seconds you want to simulate. I'll give it as 10 for this as well. So this is the leaky bucket, how it works. So here, see here for 10 seconds, the program is simulated, okay, and the rest 6 packets that is there in the bucket again simulated and given the result here. So to see this properly, yeah, you can see here the last left out packets are 6, okay, so output rate is 6 here. The packets received is 6 after this 10 second. 6, output rate is 4, right? Out of 6, 4 will be sent. The left out packets in the bucket is 2. okay, and dropped as 0. So again, this 2 will be treated as received packets. Again, that 2 will be sent out, and packets left in the bucket is 0 and dropped is also 0. This is how the leaky bucket works. Okay, and one more, the last one, CRC, right? CRC program. So again, here also I pasted this code. Directly execute this. So enter number of data bits. So in the example, I had considered 3, right? 3 as data bits. Next, execute. Enter data bits. Let me enter it as 1, 1, 0. See, one thing you do remember, I'm giving 110 as one below the other. Why? Because, please, this is very important. Do follow this. Here, I've given it as read line, right? If you are using scanner function, then it's okay if you give one after the other, leaving some space. Since I'm using read line function here, so I have to give input in this way itself. 3 data bits, right? So 110. Execute it. See, you can, after, once you enter the data bits, that is 110, for which the 16 zeros should be appended, right? See here, 16 zeros are appended for this data. Okay, that is what displayed here. After this, CRC code will be generated by applying the algorithm. So finally, this is the CRC code. Okay, now you have to check whether it is, there are errors or not. So once this data is received at the receiver end, this CRC code is received at the receiver end, you have to check is there errors or not. So for that, here it's asking enter CRC code of 19 bits. So whatever data present here, I have to give it in the with the help of standard input device. Okay, so I'll just give that. I see. Do remember I'm giving this data. Okay, here. Okay, so since standard input they have given here, so I'll just enter these values. It is 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0. Entering, if I give execution, then you can see here no error. Thank you. Okay, this is one thing. So the next thing is what if there are errors? So what you have to do, if you make any mistake while entering this, instead of 1 1, if you make it as 0 0 and 1 1, if any one bit changes while entering, then there will be error. So I want you to try out this code for error thing. Okay, yeah, that's all from my end. Do you have any doubts? Yes, if you have any doubts, we can discuss.